Okay, now testing for a group of coefficients. Okay, suppose we want to test the significance of these variables q plus 1, q plus 2, and so on. Okay, given that the first q variables are already in the regression model, okay, by adding these new variables q plus 1 through k, is that significant or not? Yeah. Alternative is that at least one of them is different, so collectively they are significant. Okay. If they are all 0, then they are not significant. So the testing methodology is to have two different models in the regression. Okay. The M1, the second one, is one that has everything in it. All variables 1 through k. Okay. Now that is the SSE of that model. We'll call that SSE1. Then we have a base model where you take away the variables that we want to test. So when you take those variables out, q plus 1 through k, you remove them. So that means what is left behind are the variables that are left behind after the ones that we are interested in. So the variables that you're not interested in, we are not testing about. It's not that you're not interested in. We are not testing about. We are not testing those variables. So keep them in. The collection of variables that you want to test, take them all out. Okay. Then that is your base model. So what happens is when you add the variables that you want to test into that model, then your SSE will go down. So from SSE0, it will go down to SSE1. So this difference is the amount of error, sum of squares, that has been decreased by the variables that you're wanting to test. So that's the key. So you define two models. How do you define the two models? The second model is all the variables in. M sub 0 is all the variables you want to test have been removed. Okay, that's what you have as M sub 0. Then you have SE sub 0 and SE sub 1. And this is your additional mean square due to the variables you want to test. And this is the SSE of the entire model. So this is what is called the additional F test. And you compare that against the F table value, where the two degrees of freedoms will be the degrees of freedom for the numerator is the number of variables you are interested in testing. Okay, and here the degrees of freedom for the SSE of the full model. And then you reject or accept. Now let's do the test in Excel. Okay, so here we are interested in these two variables, wins and losses. So we want to test whether B sub 4 is equal to B sub 5 is equal to 0 or not. Okay, if they both are not 0, then the collection is significant. So that way we will know that at least one of them is significant. They both need not be rejected, need not be not rejected. Okay, so 5%. So now let's define the models. So M1 is all of the variables in it. Now M sub 0 would be the variables that you are testing is removed. So the 4 and 5 will be removed and everything else will remain, and that will be M sub 0. Okay, so now we can define SSE of M1, SSE sub 1 and SSE sub 0. Okay, this is SSE error sum of squares for that one, for this one. So more the variables, less will be the sum of squares of error. So SSE1 is going to be smaller than SSE0. So how many variables you are now testing? Okay, two variables. So the base model, how many variables there are? Okay, the variables in the base model, which is Q. Okay, so now let us develop our list results for model M1, which is the full model, and M sub 0 is the smaller model. Okay, so there are 5 variables in M sub 1, so we need 5 slope coefficients plus one more for the intercept, and then 5 rows for output, and then we have linest. So now we shouldn't include the label. So salary, that's our Y, and then these 5 variables, then comma, comma 1, and close parenthesis, Control Shift Enter. So that will give us the output here. All right. Okay, now the M sub 0 model, we have 3 variables. So 3 plus the intercept 4 columns, and once again there is 5. Linest, again salary, don't include the label. Okay, comma. See, now conveniently for us, the remaining 3 variables that we need are adjacent to each other. But if they are not adjacent, then you have to prepare the data separately over to the side, where you put the variables that you want to include in the base model adjacent to each other. Okay, here of course we don't have to worry about that because they are already adjacent. Okay, so go like that. Okay, and then comma, comma 1, close parenthesis, Control Shift Enter. That gives us the second model. Okay. All right. Now, what is n? The number of observations. So let's do a count for that. Okay. Now k is the total number of variables. So let's do a count of everything except the intercept. So there are 5 of those. Q is the count of variables in the base model. So which is that. Now SSE1 is here. See, SSR and SSE, so that is SSE1, and SSE0 is here. Okay, so here is our additional F formula. So the numerator for F is SSE0 minus SSE1. That is the amount of error that has gone down because you've included the variables that we are interested in. And then K minus Q is the number of variables, win and lose, the 2. So that's our numerator. So the denominator is SSE sub 1 divided by n minus K minus 1. Then F is numerator divided by the denominator, and then the p-value is given by F dot this dot RT of that F, comma, the numerator degrees of freedom is K minus Q, and the denominator degrees of freedom is n minus K minus 1. So now we can set up the conclusion. Since p-value is greater than 5%, so we are not going to reject. We cannot reject. Okay, do not reject, and then we provide an interpretation. So we do not have sufficient sample evidence to conclude that the carrier wins and losses as a group, just those two variables, is significant in the regression. And if we concluded that they were significant, then the probability that the conclusion is wrong is 40.62%.